Guess who woke up and did absolutely nothing today? Not me. I woke up, goofed around for a couple of hours, and then what I actually did was, yeah, I got nothing done. It's like 9:10 p.m. Oh, why do I do this to myself? But I won't lie, you know, I spent a lot of time today editing yesterday's vlog, so that was what I did. Now it's time to actually get started on today's content. Today's content will just be implementing NESTEROV momentum within our RNN. NESTEROV's momentum, it really shouldn't take me that long, hopefully. The only thing I'm a little confused about is because, so as I said yesterday, so NESTEROV's momentum, it's kind of like momentum. That momentum, it simulates the, like if we look at it from a point of physics, it simulates the where the ball or where the gradient falls the fastest, and it directs the weights in that direction. And so that'll allow the weights and the weights to update faster, and then the error function falls much faster because it's going down the path of steepest descent. With NESTEROV's momentum, it does the same thing. However, NESTEROV's momentum, it makes use of foresight. So it tries to simulate the next time step, or the next, you know, it just tries to simulate, okay, if the ball is here right now and it goes here, where in this position is the steepest slope that I can go in, and that's that. So it basically just tries to like read the future, and so that's how that works. Now, reason why I want to implement this and I want to practice it is because, so for a normal neural network, that just means kind of simulating through one future, you know, prediction instance, and then one future backprop instance. So backprop through time, it may add some complication to that. I don't know. It could be fairly simple. I don't know yet. And that's kind of just why I want to build it out in Excel first before we actually implement it in code. So that's the plan for today. Let's get right into it. Oh, also check this out. Guess what I got for you guys? Or at least maybe more so for me, just so I don't have to constantly edit it out. But watch this. Whoa. But no, this immensely helps. It helps you guys kind of see what I'm doing as well. So what I'm going to do is I'm going to go ahead and I'm going to duplicate this. Oh, why didn't you guys say anything? I completely forgot. Guess what happened? So I trained this for another 1,000 epochs. Now I want to show you guys what has happened. It'll blow your mind. It blew my mind. So I hope you guys will be excited too. So first of all, peep the error. The error is only at 0.75, which is crazy. It means that it's learned a lot. And look at that. Look at that. Right? And this is what I find very interesting about momentum. So if we go back to now, again, you know, you can make the argument that perhaps this instance or this simulation had a better starting point because it only started with an error of 5, whereas this instance here had an error starting point of, I think, 7.5. But if you take a look at it, and you know, you could argue that this has just found a local minimum. But what I really like about momentum update is that, again, because it's simulating where the gradients will fall fastest, it looks for those points. And so you can see here, it found one such point, and then it fell, and then I think around here you can kind of see it. It then gets a little steeper again before it starts to plateau and before it starts to flatten out as it's getting more and more perfect. And guess what? It took us a while to get here, but let's take a look at the output. So time step 1, outputs an E. So you input an H, it outputs an E. Time step 2, you input HE, outputs an L. Time step 3, outputs an L. And whoa, look at that. Time step 4, it outputs an O, finally. Meaning that this network is now finally able to output the word hello. It can finally say hello. That's mind-boggling. So let's go ahead and let's start implementing NESTEROV's momentum update. I just kind of want to remind myself as to how NESTEROV's momentum works in the first place. Yeah, so if you can see here, this whole section here is basically looking at the X ahead. So the X ahead is it simulates, it tries to get foresight, tries to simulate what will happen in the future. And then in that future saying, okay, you know, there are multiple steep paths that I can take right now, but let me see what happens once I actually go down those paths. Does that stay the same, or is there, you know, a path where in the future it's not as steep now, but it'll get much steeper in the future? And so that's what it looks for. And so in order to get that, you need to then simulate the inputs again, go through, pass everything through, feed forward, and then you also want to simulate what happens when you try to backprop again. So that is the annoying part about, that's the really, really annoying part about NESTEROV's momentum. It kind of does like a half backprop simulation. Yeah, this is essentially the code that we will be using, even though no one really uses this notation in practice. I just find it much easier, so I just go ahead and I just use this. So yeah, once again, we're just going to get a look ahead for x's, and then we are going to calculate the gradients for those look ahead, like I've shown in the Excel sheet, and then we're just going to calculate our v, which is our momentum variable based off of that, and then we're going to use that to update our x, which is our weights. So let's do that. So in order to do that, oh my god, we're gonna have to add more chaos to this. Yeah, I have to do a better job at moving my mouse. It's a little shaky, so I'm gonna have to look at how to fix that. But unfortunately, that's what we're going with that today. Okay, so what I'll need to do is I'll need to go ahead. I'll need to copy all of this. And just make sure everything's getting copied. Our whole sheet, everything. Yeah, I'll just need to delete this and need to delete all these momentum variables because I don't really need them. Okay, I don't need this button. Let me just go ahead and let me just, sure, cut, why not? I will definitely paste you. Not. Okay, so then these weights will then use the weights, I'm assuming the weights in the future. Okay, so input stays the same, right? Yeah, input stays the same. These weights are, oh, okay, hold up. These weights are the old weights plus mu times v old. How the hell does that make any sense? X plus mu times v old. Oh, okay. I guess it's just the algorithm. I thought, so there's no learning rate? Okay. Okay, so that's essentially what we're gonna do, right? We're just gonna copy this. So we're gonna have our old x's, which are our old weights. We're gonna add mu times v. And because this is in Excel, we're gonna be using the old v for this. Okay, so old weight is actually not that bad. It's actually pretty simple. Yeah, remember, I hope I don't jinx it. Times, oh sorry, plus mu. I'm just gonna lock that in. Times, whatchamacallit? Where's that other? Oh, old v. Old v for weights 1. This might actually be my quickest episode yet. Again, I really hope I don't jinx it, but bias will be, we'll take the old bias, again using the same formula. Old bias plus mu. I'll lock that in. Mu is going to be multiplied by the v bias 1. V old for bias 1. Okay, so that seems to be working. And so then we pass in everything. Again, we're just simulating an instance into the future. What I need to do is you need to be equal to this guy now. Yeah, I need to, maybe because it's my first time using this, but I need to get better at using that mouse. I'm gonna have to use my mouse a lot so you guys can continuously see what it is I'm doing. That's gonna be, it's gonna be tough. I've spent so much time learning to use Excel without my mouse. It's gonna be really, really tough to use it with a mouse. Not hard, you just have to grind through this. This is just really ridiculous. Okay, I will get rid of all of these guys. Bye-bye. I will now update our momentum variable. So our momentum will now be grabbing mu times the old plus learning rate times the delta, weight 1 delta for the future. So that's the only change we really need to be making, because it's like 10, so I need to like double and triple check things. It's just that's time of the night. Okay, so let me just reset our model, Shift F9, change everything. Now it's outputting everything as an O. It's fine with me. I know it. I trust it. I know it will learn. Are we ready? Are we ready? I think we're ready. Okay, guys, hit save on that. We are good to go. So let me just hit Shift F9, let's have it calculate everything. And yeah, I mean, as far as I'm aware, I don't really need to change much. Actually, I don't need to change that button at all. I think it does the same thing, right? It copies old momentum into here, and then it copies the same set of weights. The only thing that's changed really is just rather than using this delta weights, all we're using is just the future simulated delta weights from from our look ahead function. And all right, let me hit train and I will see you guys. Actually, you know what? What I will do is, I think I'll end it there. I will train this for about 2000 epochs, get started on some quick video editing. Hopefully I can at least get some stuff edited in the next half an hour or so. Train it for about 2000 epochs, and because that's what it took for momentum to fully learn, and so I'll just do that for this as well. Might as well. I'm confident everything's going to work, and I don't need to do much troubleshooting. But if there's any updates, I'll just pick up my phone and I'll update you guys. So once again, thank you guys for watching. Comment below what was your favorite step, what was your favorite moment, what resonated with you, what was the most valuable, what was most useful, or if I got anything wrong, if there's anything you would like to see improved. Comment below, or just comment to say hi, really. But thank you guys for watching, and I will see you guys tomorrow. In an actual production, thank you. Let me actually just say that all over again with my new zoom in tool. Okay, so as I was saying, what you can see is at the beginning here, what happened is it found a very steep gradient and it followed that. I would say the section afterwards is steep as well, but then it doesn't really start plateauing until maybe like around here, like after 1000 epochs, and it starts to just plateau and just taper off a little bit. I could train it more to get the error function or get the error value even lower than this, but it doesn't really make sense because then it would just overfit, which doesn't really matter for our case because it's just like a toy example. But generally in production, you wouldn't want it to overfit, right? Because then that means that it's the more it overfits, the more it essentially just memorizes the training data. And so when you show it new data, it doesn't really know what to do because it can't. It just confuses it. It's just like us humans, right? Like if you memorize a book or if you memorize a math book, but you don't really know how to apply the concepts of it, and you go to an exam and you see newer problems that were not in the book that you memorized, you're going to get hella confused. So, but here's the part that I'm most excited about. What I'm most excited about is, wait, where'd it go? Look at this. So time step 1, we input an H into the network and it's spitting out an E. Time step 2, it's spitting out an L. Time step 3, it's spitting out another L. And time step 4, it's spitting out an O, effectively making the word hello. So our neural network can finally say hello. Or not finally, but you know what I mean. At least it's working this time when it wasn't working the first couple of times. So I'm very, very happy about this. Very, very happy about this. That's just a quick update.